Perfect. So so want to look at exponents and radicals, right? Exponents and radicals. Okay. Now, this topic is particularly important because remember I told you that in this math that we're doing, you don't use calculators, right? You don't use calculators for whatever topic it is, trigonometry, whatever it is, you don't use calculators. So this topic is particularly important when you are dealing with things involving square roots, okay? Anything involving square roots and so on, this topic is very, very important for you, all right? So now, let's say if n is, let's say if n is a natural number, right? So that is to mean if n is a positive integer, isn't it? Because natural numbers will begin from 1. Okay? If n is a positive integer uh, and let's say b is a real number, okay? And b is a real number. Then what we say is that b to the power n, okay? B to the power n is equal to b multiplied by b multiplied by b multiplied by b, and so on, right? And so on until you multiply this b by n times. You get the point? By n times, okay? Up to n times. That's what it means, isn't it? For example, an example, let's say, if we say 5 to the power 4, okay? So this is going to be 5 times 5 times 5 times what? Times 5, isn't it? Where you should have those 5s, 4 of them, all right? That's what it means, okay? Now, in this case, the number b is referred to as the base, okay? So the number b is called the base, and the number n is called the exponent, right? The exponent. So the number b here is the base, okay? So this is the base, and then this is the exponent, right? So now we need to look at properties of exponents, all right? What are some of the properties of exponents that we can look at, right? Now, the first one that we're going to look at, so we want to look at properties of exponents. Properties of exponents. So, we're saying that number one, right? If we say, let's say b to the power m multiplied by b to the power n, all right? This is going to be equal to b to the power m plus what? Plus n, okay? The power m plus n, right? So that is one property of exponent. Then, number two, or maybe let's say, let me give an example. For example, if we have, let's say, 2 to the power 3 multiplied by 2 to the power 4, this is going to be equal to 2 to the power 3 plus 4, which is equal to what? 2 to the power 2 to the power what? 7, right? And then you can evaluate the value of 2 to the power 7. Okay. I really hope I don't run out of space very soon. Okay. So then the second property that we can talk about is, let's say, b to the power m divided by b to the power n. So this is going to be equal to b to the power m minus what? Plus n. Okay. The power m plus n. Right? So that is one property of exponents. minus n, right? b to the power m minus n. An example, let me try to use a similar example. Let's say, okay, let's say 3 to the power 3 divided by 3 to the power 2. This is going to be 3 to the power 3 minus 2, which is equal to 3 to the power 1, which is simply equal to 3. All right. So that is another property of what? Of exponents. Okay. Then let's look at another property of exponents, which is very important. The third one is, let's say if we have, let's say b to the power m multiplied by, to the power n. Okay, so this is simply equal to b to the power m multiplied by n, which is equal to b to the power mn. All right. So that is another property of exponents. Another a simple example. Let's say if we have 5 to the power 2 the power 3, this is going to be equal to 5 to the power 2 by 3, which is equal to 5 to the power 6. Okay. Then another property that is very important is, let's say, that is AB to the power M. All right, AB to the power M. This is going to be equal to A to the power M multiplied by B to the power M, which is simply equal to A to the power M, B to the power M. Right. So in other words, here we simply distribute this power, or rather the exponent, to both A and B. For example, if we have, let's say, 2 by 3, then everything to the power, let's say, 2. This is going to be equal to 2 to the power 2 multiplied by 3 to the power 2, which is obviously going to be equal to, this is 4 multiplied by 9, which is going to be equal to what? 36, right? 36. Okay. So, but what is very important, what I wanted you to understand is up to that point, right? And then let's look at another one that is very important. Another property, number 5. Let's say A divided by B to the power M. All right. So in the same manner that we distributed this M to both A and B in terms when we are multiplying, we do the same also when we are dividing A and B. So this is going to be equal to A to the power M divided by B to the power M, right? So an example is, if we have, let's say, 3 divide 2 to the power 2, this is going to be 3 to the power 2 divided by 2 to the power 2, right? Which is going to be equal to 9, obviously, over 4, like that, right? So these are some of the important properties that we need to consider. And then obviously another property. Now, all these properties, by the way, like in this case, all right. So, like in this case, let's say this property here, okay. This is where obviously b should not equal to 0, all right. That is one condition that we should have. B should never be equal to 0, okay. And then remember, we can also have which one else did I give? I think there was one that I gave that I didn't talk about much. Okay. So I also gave this one. I said, let's say A divided by B, all right? Let's say to the power M, and then this one is to the power N. This is going to be equal to, all right? This is going to be equal to what? A, sorry about that. Should be b to the power m. I gave this one, b to the power m, b to the power n, divide b to the power n. This is equal to b to the power m minus what? Minus n. Now this should only be, all right. I think I didn't give this condition. This should only happen if m is greater than what? Greater than n, right? Because we don't want the power to become negative. At this point, we don't want the power to become negative. All right. Okay. And then again, this should also be if b is not equal to 0. B should never be equal to 0, because if b is equal to 0, then what are we going to have? It's going to be undefined. So those are some of the properties that that we can look at. Then the last property, the sixth property rather, that we should look at is um, b to the power negative n, right? B to the power negative n, this one is simply, it means that this is going to be equal to 1 divided by what? B to the power n. Now, obviously, when this one is provided b is not equal to 0. B should never be equal to 0. So, for example, if we say 2 to the power negative 1, all right, this is going to be equal to 1 over 2 to the power 1, which is simply equal to 1 over 2. All right. So the bit there, the base should never be equal to 0, because once it is 0, then we're going to have it as undefined. Okay. Now, let's look at some examples. I want us to look at one or two examples on how we use these exponents to solve some questions. So let's say example 1. So example 1, let's say if we have, let's say simplify the following. Let's say A, we have 3x squared, y to the power negative 4, and then multiplied by what? 4x power negative 3, and then y, then B. Okay, let's first solve this one, and then we're going to give another one. So in this case, really what we're just trying to do is to apply these principles that we're just talking about, right? So we're going to multiply the 3 and the coefficients, we multiply them, right? So 3 by 4, that is what? That is going to be 12, obviously, right? And then we're going to multiply x squared multiplied by x power negative 3. Then again we multiply y power negative 4 and y. All right. So now what we have here is we have a 12. Now these are the same bases, x and x. Now what we do when we're multiplying the same bases, what we do to the powers, we add the powers. So this is going to be x to the power 2 plus negative 3, right? And multiplied by y. Again, here we are multiplying the same bases, so we have to add the powers. Here it's the same as there's a power 1. So this is going to be negative 4 plus what? Plus 1. So this is then going to be 12. Then x, obviously this is going to be what? This is going to be negative 1 multiplied by y to the power negative 3, right? So I'm going to continue it from here. This is then going to be what? It's going to give us, now remember this property, we said that b to the power negative n is equal to 1 over b to the power n, right? So this one we're going to use that principle. So here we're going to have 12 multiplied by what? This is going to be 1 over x to the power 1, and then here we're also going to have multiplied by 1 over, or rather divided by y to the power 3. So this is then going to be equal to 12 divided by xy power 3, right? So that is how we answer such a question. So we are simply applying those principles, the few principles that we have talked about. Okay, then let's look at part B of our example. Part B of our example, let's say if we have, so this one is A, the power, this is negative 2y power 5, and then everything to the power 5. Okay. Now, here what we have is Uh, okay. So here what we have. So this should be 3. This is 5. Okay, like that. So what we have here is again we are simply trying to apply the properties of these exponents, right? So remember we had this property. We said that b to the power n is equal to a power n and b to the power n, right? So in the same, we're going to apply this power 5, this exponent to both -2 and 5 power, y power 5. So this is then going to be equal to -2 to the power 5, again y power 5 to the power 5, all right? And then this is going to be equal to what is -2 to the power 5. So -2 multiplied by itself 5 times, that is going to be what? -32, all right? And then this is going to be y to the power 5 by 5. So then this is going to be equal to what? -32. 5 by 5 is what? 25 to the power 25. So that is going to be our answer in this case. Okay, so I hope you are following. Let me give a last example so that we can look at rationalizing the denominator. Okay, so last example that we're going to look at, let's say part C. This is, we have 5x or -1, then y the squared, y squared, then over 5xy power -4, and then everything to the power -1. Okay, everything to the power -1. Right. Now, here there are several ways in which we can work out this question. All right. There are several ways in which we can work it out. Okay. Now, one of the ways in which we can work it out is first by dealing with the overall power there, which is the power -1, or we can fill with inside there. All right. So either way, we're still going to get the same answer. We're still going to get the same answer. So let's probably maybe for argument's sake, let's try to use both methods. We first deal with what is inside, and then in another case, we're going to deal first with the negative power there, the -1, so that we see if we're going to get the same answers. So ideally, we should get the same answer actually. So let's first deal with what is inside the brackets there. So remember, we are dividing. When you're dividing the same base, you subtract the powers, right? So here we have 5 divided by 5. Okay, so I'm going to try and for it up like that, 5 divided by 5. And then, now, obviously here, by the way, if you are dividing the same powers, the same bases, you subtract the powers. So this is going to be 5 to the power this is 1, there's a 1 here, so this is like 1 minus 1, all right? The other way you can deal with that is just cancel out the 5, because that's 5 and that's 5. So 5 into 5, that's a 1. As even in this case, if you say 5 to the power 1 minus 1, which is going to be 5 to the power 0, again it's going to give you a 1. So here we can simply say that the 5 and the 5 there, they are going to cancel out each other, right? And then we remain with x to the power -1, and then here the power is 1, so -1. Okay, and then we're going to also have multiplied by y to the power 2 minus the power there at the bottom, or rather in the denominator, is -4, and then everything to the power -1. So this is going to be equal to x to the power -2 multiplied by y to the power 6, right? Y to the power 6. So then this is going to be equal to what? What are we going to have? This is going to be, remember here, if we apply that principle, that is going to be 1 divided by x to the power 2, and then multiplied by y to the power 6, which is going to be equal to y to the power 6 divided by the way, there is a power -1 over x to the power 2 to the power -1. All right. Now we know that when we have a power -1 there, that is the same as 1 over y to the power what? The power 6 over x to the power 2. I'm going to bring it back this side. I'll bring it back this side. So we're going to have what? This is then going to be 1 multiplied by, right? Multiplied by, because we have to change the numerator, the denominator becomes the numerator, and then the denominator becomes the numerator. So this is going to be x squared divided by y to the power 6. So this is then going to be x squared divided by y to the power 6, and that should be our answer. So let's try. So I'm going to write it down somewhere here as our answer, x squared over y to the power 6. So let's try to deal with it where we start with a negative power outside the brackets and see if we're going to get the same answers. So our question was, I raised the question. The question was 5x negative 1 for negative 1, and then y squared over 5xy power negative 4, and then everything to the power negative 1, right? Everything to the power negative 1. Now, we can try to work it out like that. We say this is the same as 1 over everything here, that is 5x negative 1 y squared divided by 5x y negative 4, right? And this is going to be equal to what? This will be 1 multiplied by, so the denominator here, on what is at the bottom, the denominator becomes the numerator, multiplied by 5x y negative power negative 4 divided by 5x negative 1 there, then y squared, right? So it means that at this point we're going to remain with 5x y power negative 4, and then over 5x negative 1, and then y squared. Right. So what are we going to have then? We can see that the 5 and the 5 will cancel. So we're going to remain with x here and x there. X, there's a power 1 there, minus negative 1. All right, minus negative 1. Okay, so it seems my space is running out. Let me conclude and finish up. All right, and then here we have also y power negative 4 to the power negative 4 minus 2. So this is then going to be what? We're going to have x, this is x, 1 minus negative 1, that is 2, multiplied by y to the power negative 6. So the power negative 6 there, it's going to become 1 over y power 6, which is then going to be equal to x squared divided by y to the power 6. So we can see that we've gotten the same solutions, right? We've gotten the same solutions. So this is how you deal with